Hello my dear students, welcome back to the St. Joseph Composite PU College, Bijapur. Today in this video I just want to explain you the one of the important term used for the expressing the concentration of the solution, that is mole fraction. And this mole fraction is generally indicated by XI. Let's understand this concept. Now let me take an example. You have a container, and in this container you have taken minimum of two components to result the solution. For example, here this is the solvent, that's the water I'm taking here. This is a solvent. The number of moles of solvent I'm taking here, that is Na. This is the number of moles of solvent it is. And in that I will add a small amount of solute. Let take it as a Nb. Nb is the number of moles of solute. To result a solution, minimum two components are required. You can add more than two components, no issues with that. You can add Nb, Nc, Nd, so many number of solutes you can add, so many number of solvents you can add. But right now in this explanation, there are only two components are there. The one component is smaller quantity, that is solute. The one is in the larger quantity, that is solvent. Now to express the mole fraction of the solute, we need a formula, that is we can write here the mole fraction of solute, that is Xib, can be given here as the formula, that's equal to number of moles of one component, right? So that is one component is solute here. I'm calculating the mole fraction for Nb. Therefore number of moles of we can say that B, solute B, and that whole divided by number of moles of all the components. So all the components here, we can take two components are there, right? So therefore what I'll do that number of moles of all the components, instead of that what I'll do that I will take here, that is Nb is the number of moles of solute B whole divided by number of moles of all the components. You can see that there are two components are there, Nb and Na. There are two components are there. Okay, so therefore sum of the two components becomes the number of all the components, moles of all the components it becomes, right? Therefore I will write here Na plus Nb. Okay, this is a mole fraction of solute B. The same thing we can write the same way the mole fraction for the solvent also, that is the mole fraction of solvent equals to number of moles of solvent A divided by number of moles of all the components, that is Na plus Nb we can write. Okay, but very interesting fact is that the sum of Na plus that is mole fraction of A and mole fraction of B is always equals to 1. This we have to remember. It's not only for the two components, it is applicable for all the components present in a solution. Let's understand this with an example. Now assume that the formula for mole fraction of A can be given here as Na divided by Na plus Nb, and mole fraction for the B we can write here Nb divided by Na plus Nb. Okay, let's add these two components, that is mole fraction of A plus mole fraction of B equals to, so the value of Xi A is Na divided by Na plus Nb plus this one we have to add here the Nb divided by Na plus Nb we have. Now you can see that there is 1 divided by Na plus Nb are the common terms with respect to Na plus Nb. Now these two terms which are identical get cancelled. So these two terms get cancelled here, and ultimately we get the answer here equals to 1. So therefore we can say that the sum of the we can write the statement, that is sum of the moles fraction of all the components, sum of the mole fraction of all the components is unity. Okay, so therefore we can write in generally mole fraction of A plus mole fraction of B plus mole fraction of C, so on, that equals to 1. This is what we get. On this basis, we'll solve one particular problem which is given in the NCERT book. We'll solve that first. What is given? Let's have that question first. The question is quite interesting. The question, let me write the first question. They given an example. The example is you have a container, and in this container they taken the benzene. The total of 30% of benzene is present in this. So this is a solution is there, some amount of solution is there. In that 30% benzene is there. 30% benzene is present. And the remaining part is here. Let me take the benzene is present here, and along with that the chloroform is also present. Let me draw here chloroform also. The mixed colors are there. Okay, not a chloroform. We'll take here some other things like, okay, let me take carbon tetrachloride. Carbon tetrachloride. Tetrachloride I will take. Okay. Now there are two components are there. This is the solution. Now we have to calculate the mole fraction of carbon tetrachloride and mole fraction of benzene. Okay. This information is provided. Now we can list some things here. So we go for the solution. Solution is there. The mass of solution. Mass of solution we can write here, that is 100 grams. 100% is there, percentage we can convert it to the gram. Then mass of benzene is equal to 30 gram because it is given 30%, no, therefore we'll take 30 grams. Then mass of CCl4 carbon tetrachloride, we can write here 100 minus 30, that is equal to 70 grams. Okay, these are the three things we can list now from given data. After this, now we go for the calculation of mole fraction. To calculate the mole fraction, we need here number of moles. Therefore, number of moles of benzene, that is C6H6, can be calculated. The given weight of the benzene is 30 divided by the molecular mass of the benzene is 78. Hope you know these basic things. I don't want to explain in this video, otherwise the video becomes very long. And when you cancel these two terms, you will find that the 30 and 78 get cancelled, and the answer for this one we get, that is equal to, that is 0.3846 we get. Okay, this is the number of moles of benzene we got in this. The same thing we have to do for the CCl4 carbon tetrachloride. That is equal to the given mass of carbon tetrachloride is 70. Let me write it 70 grams. And carbon tetrachloride mass, okay, the 4 times into 35.5 into 12 plus 12, it is 154. Now these two terms get cancelled. Okay, and after that we get the value. Okay, let me take some values here. This is equals to, we get here 0.4545. These are the number of moles of carbon tetrachloride in that solution, particular solution. Now the thing become very easy here now. Now mole fraction of C6H6 will take C6H6, and that is equal to number of moles of C6H6 whole divided by number of moles of all the components present in the solution, that is number of moles of C6H6 plus number of moles of CCl4. Now what I'll do, that the number of moles of benzene, that is here it is given, let me write that 0.384 and 6. Then I'm going to sum these two and divide the above the numerator. Let me write 0.3846 plus and CCl4, that is 0. Here it is given, that is 0.4545. This is what we get. After simplifying the mole fraction of benzene C6H6, we can calculate and we get the value. The value is 0.454583. This is the mole fraction of benzene in the solution. So next part we can calculate by two methods. One is a method 1. So where we are following the same process of mole fraction of CCl4, that's equal to number of moles of CCl4 and whole divided by number of moles of CCl4 plus number of moles of C6H6 is there. Now what I'll do, that number of moles of CCl4, the values that is okay, I remember that 0.4545 is there, okay, and whole divided by the sum of the number of moles of CCl4 and benzene. Here it is there, okay, that is 0.4545 plus the benzene, that is 0.3846 we have. Now after solving this, we get the answer. The answer is 0.5417 we get. Okay, there is one more method is there. Second method, method 2. So in the second method, what we'll do that? We'll now think about the sum of the mole fraction of all the components in the solution or unity. That is n of mole fraction of C6H6 plus mole fraction of CCl4 carbon tetrachloride is equals to 1. Now I don't know that what is the mole fraction of CCl4. In this method 2 if solved it is, but initially we don't know that. We know that only the mole fraction of benzene, that is mole fraction of benzene we can write here, that is 0.4583 plus this is unknown, keep as it is, CCl4, that's equal to 1. Now mole fraction of CCl4 equals to 1 minus 0.4583, and that's again equals to, we get the same answer here what we get here, at 0.5417. Okay, this is all about the mole fraction, students. Hope you understood this. The remaining part we'll discuss in the next video, students. Thank you for watching it.